Hi, my name is Martina. I am originally from Italy and currently I am a postdoctoral scholar in the Department of Civil, Environmental and Geodetic Engineering here at The Ohio State University. Associate Professor Jeffrey Bellicki is my supervisor. We do research on energy system, carbon management, renewable energy, and their integration. Two major challenges for modern energy systems are to increase electricity generation from renewable sources and decrease, stop, and reverse CO2 emission to the atmosphere. How can we do that? CO2 can be captured and stored through processes that permanently isolate it from the atmosphere by emplacing CO2 into deep saline aquifers. These are reservoirs made of permeable rock deep below the surface. They contain salty water and you can find them in many places worldwide. Deep saline aquifers are a good place to store CO2 and they can contain renewable geothermal energy. This energy is in the form of heat and CO2 can be used to bring it up to the surface to production wells. Therefore, we are developing new technology to integrate CO2 capture and storage and geothermal energy production. Our work shows that geothermal energy can be produced while circulating geologically stored CO2 between the subsurface and a power plant. Thus, some of the CO2 molecules are utilized to extract geothermal heat and to spin a turbine, and all of them are eventually stored underground. This integrated process is called CO2-driven geothermal utilization and can be coupled to and increase the efficiency of processes that extract CO2 from the atmosphere. In addition, geothermal energy is constant and can be dispatched as needed. This means that a geothermal plant can meet fluctuating needs, such as those caused by intermittencies of solar and wind power. We believe that society must transition the way we use energy for our economies in order to save the environment upon which we depend. Innovative ways to isolate CO2 from the atmosphere and use it to produce renewable energy can help move society toward an energy future that is environmentally, economically, and socially benign. It can do so by reducing the causes of climate change, its environmental consequences, and the associated impacts to our livelihoods.